In today's lessons, you will learn angle congruence theorems. In today's lessons, you will learn and apply the three triangle congruence theorems. These are the angle-side angle, side-angle-side, and side-side-side congruence postulates. Triangles can be similar or congruent. Similar triangles will have congruent angles but sides of different lengths. Two triangles are congruent if their corresponding sides are equal in length and their corresponding interior angles are equal in measure. We use this symbol to show congruence. Remember, corresponding sides and angles means that the side on one triangle and the side on the other triangle in the same position match. You may have to rotate one triangle to make a careful comparison and find corresponding parts. Testing to see if triangles are congruent involves three postulates: angle-side angle, abbreviated ASA, side-angle-side, abbreviated SAS, and side-side-side, abbreviated SSS. Let's take a look at the three postulates, starting with the angle-side angle or ASA postulate. This postulate says triangles are congruent if any two angles and their included side are equal in the triangles. An included side is the side between two angles. Let's compare two triangles, triangle CAT and triangle BUG. Notice that angle C on triangle CAT is congruent to angle B on triangle BUG, and angle A on triangle CAT is congruent to angle U on triangle BUG. See the included side between angle C and angle A on triangle CAT? It is equal in length to the included side between angle B and angle U on triangle BUG. The two triangles have two angles congruent and the included side between those angles congruent. This forces the remaining angle on our triangle CAT to be 180 degrees minus angle C minus angle A. This is because interior angles of triangles add to 180 degrees. The postulate says you can pick any two angles and their included side. Next, we have the side-angle-side postulate, or SAS. Here, instead of picking two angles, we pick a side and its corresponding side on two triangles. The SAS postulate says that triangles are congruent if any pair of corresponding sides and their included angle are congruent. Pick any side of triangle JOB. This works no matter where you start. Move to the next side, in whichever direction you want to move, which will sweep up an included angle. For the two triangles to be congruent, those three parts of triangle JOB, a side, included angle, and adjacent side, must be congruent to the same three parts, the corresponding side, angle, and adjacent side on the other triangle, triangle YAK. Next is perhaps the easiest of the three postulates, the side-side-side or SSS postulate. This postulate says triangles are congruent if three sides of one triangle are congruent to the corresponding sides of the other triangle. This is the only postulate that does not deal with angles. You can replicate the SSS postulate using two straight objects. Uncooked spaghetti or plastic straws work great. Cut a tiny bit off one, so it is not quite as long as it started out. Cut the other length into two distinctly unequal parts. Now you have three sides of a triangle. Put them together. You have one triangle. Now shuffle the sides around and try to put them together in a different way to make a different triangle. No matter what you try, you can't do it. You can only assemble your triangle in one way. You can simply switch two sides around, but then all you have is a reflection or a mirror image of the original triangle. Once you realize that three lengths can only make one triangle, you can see that two triangles with their three sides corresponding to each other are identical or congruent. Using these three triangle congruence postulates, the side-angle-side congruence postulate, angle-side-angle congruence postulate, and the side-side-side congruence postulate, you can now determine if any two triangles are congruent.